And the radius, right? The sun's going to expand, and by the time of the helium flash, it's going to be about the size of the Earth's orbit. So hopefully we're on Mars, but actually that won't help either. We need to be further away than that. But the time periods of these don't take that long. The thermal pulses, the formation of the planetary nebula is going to be essentially tens of thousands of years, right? Up to a million years. Right? That's just not a big change. And I lost track of the time. So hopefully I'll know where I stop. All right. So now we're going to talk about high mass stars. All right. So the thing that stopped the low mass star from fusing is that there just wasn't enough energy to force the carbon and oxygen to fuse. There wasn't enough contraction and temperature increase. Right? And so you're left with this core that makes up the white dwarf. If you have a larger mass, you can have that. And so here we have a star that has lots of other stuff in it. All right, this is a remnant of a supergiant that's being, formed outwards. But the star is massive and it's forming other elements. So to actually get this sort of other stuff going on, um, is not necessarily the most efficient to do the standard fusion that we've been doing. Because once you have carbon and oxygen and nitrogen as catalysts, you have a new cycle that can burn fuel faster, produces the energy faster. And that's part of why high mass stars burn fuel so fast, is now they have new ways of burning it. And so there's a cycle of starting with uh, remnants, carbon, nitrogen, and oxygen as catalysts, taking in taking in protons and eventually forming a helium nucleus. And it basically does the same thing as the primary cycle, but it occurs, it occurs faster. Right? So the late stages, you're still going to have hydrogen fusing on the main sequence. You're going to have shell burning. You're going to have helium fusion. But then eventually, you're trying to form heavier elements. Some oxygen will form when carbon fuses with helium. Some neon will form when oxygen fuses with helium. And then, you keep going on. Magnesium forms basically elements you can reach, but just tacking on helium to other elements, you'll have form. These are what are called helium capture reactions. And so when we start out in the Big Bang, you just have hydrogen and helium. Main sequence stars and low mass stars will eventually get you to carbon. And then the heavier stuff will get you carbon and nitrogen and oxygen. And then you'll start building up the heavier and heavier elements. And it goes up basically by masses. All right, so after magnesium, you'll get silicon, you'll get sulfur, you'll get argon, and so on. And eventually, we'll start fusing these things together. All right, eventually, we'll start fusing heavier, carbon with oxygen, or oxygen with oxygen, or silicon with itself. And so eventually, we're building up to iron. That's going to be our goal. And each time, you're going to have this pulsing that, the shell starts to burn. You'll have some growth. And then the core will heat up enough for it to start. And so you're going to have an onion that forms around it. All right. So, we're just describing, we're not exactly sure what these onions are, is that they can be mixtures of various elements, but eventually the core is going to be iron and lighter elements will be outwards in the layers.